Hello, welcome back. Today we're going to be graphing equations in standard form without a graphing calculator. The objective is by the end of this video you should be able to draw a graph of a quadratic function in standard form by finding the function's vertex and axis of symmetry, again without a graphing calculator. To get us started, we've got some vocabulary. The first word is the parent quadratic function, which is f of x equals x squared. Note that we often exchange f of x, which means a function of x, with the variable y. Means the same thing, just slightly different notation. It is the simplest form of a quadratic equation. Now, the standard form of a quadratic function is where all the terms of the function are listed from highest exponent to lowest exponent. And it looks like this. F of x equals ax squared plus bx plus c, where a, b, and c are real numbers. And an example would be y equals 3x squared minus 5x plus 2. Notice the x squared comes first, then the x, then our constant term that does not have a variable comes at the end. Now, a quadratic function will always make a u-shape that is called a parabola. So I've got a couple of examples of some parabolas. The blue shape is a parabola, and so is the red shape. And both of these came from quadratic functions that were graphed. Now, if we take a look at these parabolas, we'll notice that each one of them has something called a vertex. Now, a vertex of a quadratic function is the highest maximum value or lowest minimum value on the function's graph. Looking at these two graphs, we'll notice that the one in red has a maximum for our vertex. The one in blue has a minimum value. It's the lowest value on its particular graph. Which is going to bring us to, in a second, our last term, which is axis of symmetry. The axis of symmetry of a quadratic function is a line that splits the function in half. Now, the axis of symmetry always passes through the vertex. So if we look at our equation, or rather our graph in red, you'll notice that we can split that graph exactly in half by cutting through this line right here. So this line has a value of -4, and if you'll notice, all the points are mirror images of each other across that axis of symmetry. Now, that's just an important thing to note. It's going to make graphing a little easier in a moment. Now, we can tell whether or not a quadratic equation or function has a minimum or maximum value without ever having to actually graph a function. The way we can do this is by noting that a quadratic function's vertex is the function's least or minimum value if the parabola opens up, meaning the a value, the leading coefficient of our function written in standard form, is bigger than 1. The vertex is the function's maximum value if the parabola opens down, and that happens when your a value is less than 0. Now, taking a look at a couple of examples, we'll notice that our first example, 4x squared minus 3x plus 17, notice that it is written in standard form. Y is equal to ax squared plus bx plus c. Now, your a value is your leading coefficient, your number next to the variable with the largest exponent. And that number is a positive 4, which means that our parabola, since it's a positive 4, should open up. Which means that, do we have a minimum or maximum value for our vertex? Well, our vertex is the lowest point, so it would be a minimum. For the second example, is it a minimum or is it a maximum? Rather, is the vertex a minimum or is the vertex a maximum? Looking at it, you notice that the leading coefficient is a negative, understood to be 1, which means that the parabola will be opening down, which means that you will have a maximum value for the second one. And we had a minimum value for the first. So again, if your leading coefficient or your a value is positive, you'll have a minimum for the vertex. If the a value is negative, you'll have a maximum for the vertex. And you can relate this to transformations, because if your leading coefficient was negative, remember that we had to reflect the graph over the x-axis, which made it point down. Another way to remember it is positive points up or opens up, negative opens down. We can also find the axis of symmetry of a function, quadratic function, in standard form by using the following equation or formula. If we're given a quadratic function in standard form, we can find the axis of symmetry by using x equals negative b over 2a. And again, the b and the 2a come from the coefficients of a quadratic function written in standard form. Now, we can also find the vertex of a quadratic function in standard form by finding the axis of symmetry and then substituting the value of the axis of symmetry into your function for x and then solving for y. In other words, the axis of symmetry formula gives us the x value. We can solve for the y value by substituting that x value back into our equation. Now all this is going to lead us into really the goal of today, which is to graph a quadratic function in standard form without a graphing calculator. And the way we're going to do this is we're going to find the axis of symmetry, then we're going to use that x value to find the vertex, as stated before. Then we're going to plot the axis of symmetry in the vertex. We're going to pick a couple of x values bigger than the vertex, substitute those in for x, solve for y, plot the new points, reflect the points over the x symmetry, and then graph the parabola. Sounds like a lot of work, but it actually goes fairly quickly. And what I'm going to do is I'm going to show you an example where we're going to work through all of this together. So for our first example, we've got y equals 3x squared plus 12x plus 5, and we're going to end up graphing this function without a graphing calculator. Now, first thing we need to do is identify the a, b, and c. We're going to use that for axis of symmetry formula. Our a is 3, since it's our leading coefficient. Our b is 12, and our c is 5. Now we're going to use that a and b to find our axis of symmetry, which our axis of symmetry formula was x equals the opposite of b over 2a. So all we got to do is substitute in the b and the a value into that formula. So our b value is 12, so it's negative 12 over 2a, 2 times 3. So it's negative 12 over 6, which gives us negative 2. Now notice our axis of symmetry is x equals negative 2. Now we're going to use that x value to find our y value of the vertex. So now that we know what x is, we can substitute that x value in. I'm going to put it right here in our table. And I get 3, y is equal to 3 times negative 2 squared plus 12 times negative 2 plus 5. So 3 times negative 2 squared, we have to evaluate this expression in the order of operations, or PEMDAS. So we get 3 times negative 2 squared, exponents comes first, so 3 times 4, plus 12 times negative 2 is minus 24, plus 5. 3 times 4 is 12, so we get 12 minus 24 plus 5. And we add and subtract from left to right. So 12 minus 24 is negative 12 plus 5, which in the end gives us a negative 7. So our vertex should be negative 2, comma, negative 7. Negative 2, negative 7. So I've plotted my vertex, and I'm also going to plot my axis of symmetry. X equals negative 2 is a vertical line that passes up and down through the x value of negative 2. Now what we need to do is pick a couple values after our vertex so that we can get a couple more points to make the parabola. Now, a point after negative 2 is negative 1 and 0. So all we're going to do is we're going to substitute that negative 1 and that 0 in for our x's and solve for our y's. So negative 1, substitute that in for x. We get y is equal to 3 times negative 1 squared plus 12 times negative 1 plus 5. So y is equal to negative 1 squared is 1, so 3 times 1 plus 12 times negative 1 plus 5. 3 times 1 is 3. 12 times negative 1 is negative 12. Plus 5. 3 minus 12 is negative 9. Plus 5, which is negative 4. So we get negative 1 comma negative 4 as another point. And 0 is a lot easier to substitute in because when we put 0 in for those x values, it's going to make finding the y a very quick process, giving us y is equal to 3 times 0 squared plus 12 times 0 plus 5. And 0 squared is just 0, times 3 is 0, plus 12 times 0 is 0, which means y is equal to 5. So we get 0 comma 5 as our last value. Now if you try to connect those, you're going to end up with just part of a parabola, half of it actually, and that's really poorly drawn, but it should give us half of a U-like shape. Now what's so useful or nice about this axis of symmetry, and the whole point of finding it in the first place, is because now that we know our values to the right, we can just reflect those over the axis of symmetry to find the values to the left. Because remember, the axis of symmetry splits the parabola in half, and this saves us half of all of this work I was doing to the right. All I gotta do is reflect these points. Since it's 1 away from the line, I go 1 to the other side. Since this was 2 away from the line, I go 2 to the other side. And I've just created this other half of my parabola without having to do much math, or rather any math at all, except for a little bit of counting. And there you go, you've graphed a parabola in standard form by finding the axis of symmetry, substituting that value in, finding the vertex, picking a couple points after the vertex, plotting those, and reflecting over the axis of symmetry, and then plotting them all to create your parabola shape. By the way, this is a minimum, or rather our vertex is a minimum because our parabola opens up, or because the a value was positive. Now I've got an example for you to try on your own, at least to get started on. This one does include a fraction, so if you need a review on how to divide by a fraction, I'm going to do it here in a second. But if you feel like you can divide by a fraction and want to give this a try, go ahead and pause the video, work it out, and press play when you're ready to see the answer. Alright, for this one, again, we notice that the a, b, and c values we need to find first. So the a is negative 1/3. The b, notice there's no x term, so your b value is 0, and your c is 2. So our axis of symmetry is x equals negative b over twice a. Since b is 0, we get negative 0 over 2 times a, which is negative 1/3. And y'all, 0 over anything is just 0, so that makes finding our axis of symmetry very easy. It's 0. Now that we know what x is, we need to substitute that x value back in and find our y value. So we put 0 in for x, and we get y is equal to negative 1/3 times 0 squared plus 2. Negative 1/3 times 0 squared, that's just 0, plus 2 is 2. So our vertex is 0, 2. Now we know that this is a maximum value without ever graphing because our leading coefficient is negative 1/3, which means it opens down. Our parabola opens down, and our vertex is a maximum. Alright, so what we're going to do now is we need to find a couple points after x of 0. So we're going to choose 1 and 2. We can choose 1 and 2, but as soon as I think about that, I know I'm going to be multiplying those by a 1/3 here in a second after squaring them. So let me choose values that are divisible by 3. It's going to make the math a lot easier. You didn't have to do that, but boy, it makes the math a lot easier when we multiply by 1/3 here in a second. So I'm going to choose 3 and 6. Again, I'm doing that because I know I'm going to be multiplying by a 1/3, and it makes it a lot easier to multiply 1/3 times 3 and 6 than it does like 1 and 2. So I'm going to get y equals negative 1/3 times 3 squared plus 2. It's negative 1/3. 3 squared is 9 plus 2. Negative 1/3 of 9. That's the same thing as 9 over 1. So we get, and we multiply top to top and bottom to bottom. This gives us, I'm going to do this down here, negative 9/3 plus 2. Negative 9/3 is a negative 3 plus 2, which means it's a negative 1. Now we're going to use a very similar process when we try to substitute in. Instead of 3, we're going to substitute in 6. So we get 6 squared, which is 36. So we get negative 1/3 of 36 plus 2. And 1/3 of 36 is a negative 12 plus 2, which is a negative 10. So that's actually a little bit off the graph, so I'm going to move the graph a little bit down so we can see what's going on. And in order to help us graph, so I went ahead and plotted our points and also our axis of symmetry, which is going to make the graphing a lot easier. We notice this point is 1, 2, 3, 4 away from our axis of symmetry. Ooh, excuse me, our axis of symmetry should have been x equals 0. That point got just a little bit off. So it was 0, 2, 3, negative 1, and 6, negative 10. So in this case, our axis of symmetry is actually on top of our y-axis. We notice this is 3 away from the axis. We're going to go 3 on the other side of our axis of symmetry. This one is 6 away, so we're going to go 6 to the other side of our axis of symmetry. We connect the dots in our U shape, and we have graphed another parabola. Again, it had a maximum.